Hello everyone, my name is François Massonnet. I'm a postdoctoral researcher at UCL Belgium and I have been involved in the year of polar prediction since 2015. I would have really liked to be with you in person in Madison, but I had scheduled my holidays since a while and it was not possible for me to come over. Nevertheless, I wanted to share with you some results regarding sea ice prediction in the Southern Ocean and a project that I'm leading as part of the YOPP Southern Hemisphere, and the project is named SIP South. But to start with, I want to tell you a little story. This is the UK Royal Research Ship James Clerk Ross, and in February 2018 the ship was heading for a scientific mission to the eastern part of the Antarctic Peninsula, more precisely to the Larsen Sea region, in order to investigate the consequences of the calving of a massive iceberg 7 months earlier in July 2017. However, and quite unexpectedly, the ship got stuck in the very thick ice and it had to turn back without being able to reach its final destination. We all know that the preparation of expeditions like this one are extremely expensive in economic terms, but also logistically speaking. So having the ship obliged to turn back is actually very worrying. So here we can ask two questions. The first one being, is it possible at all to predict the Southern Ocean sea ice conditions before the ship leaves its base towards its final destination? And second, how are the current sea ice prediction systems doing at timescales of a few weeks to a few months? I'll be quite quick on the first question because the goal here is not to make a comprehensive assessment of all the mechanisms that are thought to give seasonal sea ice predictability, but the current knowledge indicates that yes, sea ice is in theory potentially predictable months in advance. What you see on the screen is a measure of the predictability of the sea ice edge, with 1 meaning fully predictable and 0 meaning not predictable, according to a climate model. And there are two interesting things to note here. The first one being that you have this eastward propagation of the predictability signal owing to the advection of sea ice by the winds and by the ocean currents. And second, you have the existence of intermittency in the sea ice predictability. What several articles have shown is that the upper ocean can actually store predictability from the sea ice during the summer month, and the ocean can resurface or can re-emerge that predictability back to the sea ice during the next fall. So in one word, yes, sea ice is thought to be predictable even if it is highly seasonal in the Southern Ocean, and this is mostly thanks to the coupling of sea ice with the ocean beneath. As for the second question, things are less settled, and this is precisely the reason why the SIP South project was launched. So the Sea Ice Prediction Network South is a 2-year program that is aligned with the year of polar prediction. The project has basically 3 strategic objectives, the first one being a hub or a focal point for hosting seasonal predictions of Antarctic sea ice. The second one is being a way to keep the community aware and up to date regarding Antarctic sea ice news, for example, extreme events, polynias or high or low records and things like that. And the third objective of the SIP South is to coordinate a real prediction exercise during the special observing period of the YOPP in the Southern Hemisphere, which will take place in Austral's summer 2018-2019. And SIP South is quite particular in that it is one of the 2 out of 77 YOPP-endorsed projects that investigates an Antarctic sea ice related question, while all the other projects are either Arctic focused or they are atmosphere focused or they are both. And this figure also illustrates in a different way why it is so pressing to have a dedicated project on Southern Ocean sea ice prediction. The first big milestone of SIP in South has been the coordination of a first set of forecasts collected in December 2017 and targeting February 2018. For this very first exercise, not less than 13 groups participated, which was just great, and they submitted a total of 160 forecasts. The vast majority of the forecasts were done with coupled dynamical models, but we also received a few contributions based on statistical models. So here we are. This figure shows the total Antarctic sea ice area for each day of February 2018 as forecast 2 months earlier from December on. And the two black lines show two observational references to give you an idea of where the actual total sea ice area was. The first striking conclusion here is that the intermodal spread is extremely large, but still the observed values lie within the model range, and that in a way it's kind of good news because it means that the models don't seem to display collectively a systematic deficiency in forecasting total Antarctic sea ice area. Now we should be careful about that because total Antarctic sea ice area can be a very misleading diagnostic, and it might hide regional errors that we should investigate. So that's why we then looked at the monthly mean sea ice area, but this time expressed as a function of longitude. And quite surprisingly, one region completely stood out of the whole set of regions, and that's the Ross Sea and the Amundsen-Bellingshausen Seas region. Before we try to understand what's going on here with the models, we should maybe make a replay of the synoptic conditions in January 2018 in the Ross Sea. And the map here shows the mean sea level pressure taken from a very nice visualization website on the 14th of January 2018. Red means that you have low pressure systems, and yellow means high pressure. Now I'm going to move forward in time, day by day, and you see that on the 16th of January a quite intense cyclone developed in the Amundsen Sea and persisted there for a few days, bringing in very warm air over sea ice, but also dynamically cracking the ice and thereby accelerating the ice albedo effect. We are here at the very end of the spring season. We are nearing the annual minimum, and this cyclone has had the effect to really speed up the ice retreat. This event lasted for only about a week, but it certainly had a major impact on the strong anomaly that we saw in the observational records. Now, why don't the models get that anomaly? Well, that's another question, and as we all know, at lead times of a few weeks to a few months, the occurrence of such big cyclones is basically unpredictable because weather is unpredictable beyond a few days. But it could be expected that among the multiple members of each model, at least one or several members would catch or would have such an unusual weather event. And here it looks like none of the forecast systems did really experience observed conditions, and this might point towards a systematic deficiency in the models. I'd like to finish the presentation by saying a word on how useful the forecast can be. So far I've talked a lot about sea ice area, which is quite an abstract quantity for end users or people operating vessels, for example. And in SIP in South, we also wanted to propose visual ways to communicate information from forecast to the stakeholders or to the users. And the 5 panels that you see on the screen show the probability of ice presence as forecasted by 5 climate models that participated to the SIP in South project. The probability of ice presence here is defined as the fraction of ensemble members with more than 15% of ice concentration. And this type of maps can be very useful because they can be very easily interpreted by people without any experience in climate modeling or in sea ice modeling, because green means you can go, red means you cannot go, and orange means you should be careful about going. And that's a very visual way to interpret the forecast. So to conclude that second part in the presentation, this initial forecasting experiment has shown that the forecast may actually well have systematic errors, but we will need to wait for more experiments like this one to confirm that this is actually the case. We don't really know if that event in the Ross Sea was just an accident or if it's indicative of a true inability of the models to forecast some things there. In any case, it's important to remember that the goal of SIP in South is to understand why the forecasts are wrong, rather than convincing ourselves that they are good. And we know that there are still a lot of aspects to improving the models, and we hope that SIP in South can be helpful in that respect. So that's it. Thanks for listening. For more information on the project, you can browse the SIP in South website, or you can contact me. That's also the case if you would like to contribute forecasts for the next exercise. There will be a major exercise in November 2018, so in a few months from now, where we will try to deliver forecasts for the special observing period of the YOPP. So don't hesitate to drop me an email or to browse the website if you are willing to contribute. I finally mentioned that all the data that I've shown and all the figures that I've been showing on the screen, they're available publicly and they can be reprocessed because all the data of the project, they are archived on a public server, public Git server that anyone can access. Thank you very much for your attention.